هذا الفيديو complex numbers هو عبارة عن حل exercises عن فكرة how to prove that a triangle is a right angled triangle باستخدام الأربع طرق اللي تعلمناهم بالفيديو السابق. بلش بإكزامبل نمبر 1. هيدا التريانجل مثل ما انتم شايفين OM prime. As we know أن الأفكس للO هي على طول 0. So the coordinates of the points O هي 0 0. الآن عاطيني الأفكس لإلها plus 2i إذا بدي أكتبها على شكل image يعني 0 2. الآن برايم الأفكس تاعولها معتمد على الأفكس of m. وأي اللي براهني إنه التريانجل هيدا right angled triangle. أنا كتلميذة باك 2 هون بعرف 4 طرق لبرهن إنه التريانجل right. طبعا أنا فيني أختار الطريقة اللي بدي إياها. رح أشتغل أنا وياكم هيدا السؤال باستخدام فكرة converse of Pythagoras theorem. طبعا مثل ما قلنا من شوي بس لأقول converse of Pythagoras theorem أول شغلة بدها تخطر ببالي هي قصة الموديولس. أول شي رح طلع السيجمنت OM على شكل موديولس ZM minus ZO. Z للO إنها 0 والZ للM according to the given هي عبارة عن plus 2i. As we know, لنطلع المodulus of any complex number, we use the following formula, which is radical x squared plus y squared. So the measure of the side OM is equal to. طلعنا ال OM. هلا رح طلع side OM prime by using the modulus formula. هي ZM prime minus ZO. ZO is equal to 0. Z للM prime معيها given. I'm going to replace ZM prime by the following quantity. طبعا في بيناتهم إشارة multiplication والproperties للموديولس بتقول بحق لي وزع الموديولس على الأول complex number موجود عندي وعلى ثاني complex number موجود عندي. So I'm going to distribute now the modulus. في بيناتهم إشارة multiplication بننزل إشارة multiplication. هيدا complex number لطلع الموديولس لإله we apply the following rule radical x squared plus y squared. يعني 1 square which is equal to 1 radical 3 square which is equal to 3 1 plus 3 gives 4 radical 4 gives 2. So the modulus of 1 plus I radical 3 is equal to modulus of Z is equal to كمان 2 times 2 gives 4 and the measure of OM prime is equal to 4. Well, in order to show that the triangle OM prime is right by applying the converse of Pythagoras theorem, I need to find the length of M prime as a final step. How to determine M prime? I'm going to apply the following rule of modulus. Z للM prime معيها given اللي هي 1 plus I radical 3Z and Z of M is equal to Z. I'm going to distribute Z. فبتصير Z times 1 gives Z. Z multiplied by I radical 3 gives I radical 3Z minus Z. Z minus Z will cancel each other. Again, there exists a multiplication sign. I'm going to distribute the modulus over I radical 3 and over Z. How to determine the modulus of the following complex number? I simply apply the rule radical x squared plus y squared. Only no real parts, so x squared is equal to 0 squared. Y squared, y is equal to radical 3. Radical 3 squared gives you 3. So the modulus of I radical 3 is equal to radical 3. And modulus of Z it is given, which is equal to Radically 3 multiplied by 2 gives 2 radically 3, and m prime in this case is equal to radically 3. How to show that the triangle is right? I simply square all the sides. 4 squared gives 16. 2 squared gives 4. So radically 3 squared gives 12. Adding the smallest sides, 12 plus 4 gives 16, which is equal to the largest sides. So we can conclude that OM prime squared is equal to OM squared plus MM prime squared. And now we can say that the triangle OM prime is a right-angled triangle by using the converse of Pythagoras theorem. Another example concerning right-angled triangles are complex numbers. The O, as we know that the affix of the points O is denoted by 0 and the image of the points O are respectively 0, 0. Z of M is given. It is written in algebraic form. Z of M prime, it is also given. In the first part, it is required to write Z prime in algebraic form. So we are going to replace Z now by 1 plus I. And we are going to expand multiplying first by first, first by second, second by first, and second by second. Don't forget that I squared in complex number is always equal to minus 1. Separating the real parts and the imaginary parts, we get that Z prime is written in the following algebraic form. So the first part was about writing Z prime in algebraic form. Here it's done. And now how to prove that the following triangle OM prime is a right angled triangle. مثل ما تعرفنا في عنا 4 طرق لنبرهن التريانجل right. ممكن استخدم converse of Pythagoras، ممكن استخدم dots product، ممكن استخدم slopes، ممكن استخدم فكرة arguments. Here I'm going to apply the concept of the dots product. But the right angle تكون at O يعني we have to show that the two vectors OM and OM prime are orthogonal to each other. How to show that these two vectors are orthogonal? Let's determine the components of vector OM, then the vector OM prime. Find their dots product. If their dots product is equal to 0, this implies that the two lines are orthogonal to each other. And in this case, we can say that the triangle OM prime is a right-angled triangle. So let's begin. The affix of the point M is given by 1 plus I. We can say that the image of the point M is 1, 1. M prime هلا بعدنا من شوي مطلعين الافكس تاعولها بهيدا الشكل. فيني اخذ الايمج اللي هو الريل بارت minus 1 minus radical 3 and the imaginary part اللي هو 1 plus radical 3. والاو مثل ما حكينا انه دائما 0 0. من الاو اللي هي 0 0 من البوينتس ام بقدر طلع الفيكتور او ام xm minus xo ym minus yo. In a similar way, I'm going to find the components of the vector OM prime, which is x of M prime minus x of O, y of M prime minus y of O. طلعنا two vectors. هلا بدي أعمل لهم dot product باستخدام قاعدة x prime plus y prime. So I'm going to multiply x by x and y by y. The result is 0. So the dot product between these two vectors is equal to 0. We can say that OM and OM prime are orthogonal to each other. Orthogonal يعني there exists an angle equal to 90 degrees. And we can say that OM prime is a right-angled triangle at O by using the methods of dot product. So the dot product is equal to 0. The two lines are perpendicular to each other. The triangle OM M prime is a right angled triangle. في هيدا الإكزامبل عم يطلب مني إني أكتب الإكسبوننشال form z of b على z of a. هلا z of a it is written in algebraic form, z of b it is written in algebraic form. أول شي رح حطهم بهيدا الشكل. هيدي واضح إنه it is real part so ما بقدر أقرب عليها نهائي. هيدي بقدر أكتبها in exponential form مثل ما تعلمنا بالفيديوز اللي قبل. و 2 plus 2i كمان بقدر أحولها ل exponential form. So prepare yourself. 1 plus radical 3 رح ننزلها مثل ما هي. minus 1 plus i رح طلع لها modulus ورح طلع لها arguments بالطريقة اللي تعلمناها. هيك بنكون كتبناها in exponential form. Repeat a similar procedure. Let 2 plus 2i. Determine modulus, determine arguments. We will get that 2 plus 2i is written as 2 radical 2 e to the power I pi over 4 in exponential form. هيدي ما قدرت أقرب عليها نهائي لسبب إنه it doesn't contain any imaginary parts so اللي بنعمله إنه simply بننزلها. هيدي ما تركتها in algebraic form حولتها ل exponential form و similarly 2 plus 2i عملت لها conversion into an exponential form. اللي رح أعمله هلا إنه radical 2 and radical 2 will cancel each other. صار عندي 1 plus radical 3 بالنيوميريتور و 2 بالدينومينيتور. هيدي رح أرفعها لفوق. So I'm going to change its sign. فبدل ما تكون plus pi over 4 رح تصير minus pi over 4. 3 pi نقصوا منها pi هي 2 pi over 4. أعمله simplify by dividing its terms by 2. وصلنا لهيدا الأنسر. هيك بنكون كتبنا ZB over ZA in exponential form as it is required from us. هلا we have to prove that the triangle OAB is a right angled triangle. بس أنا بدي برهن right angled triangle يعني لازم angle pi over 2 لاقيها بقلب ال triangle. So رح اختار 2 vectors لأنه بده إياها right at O. بدي اختار 2 vectors ببلشوا بحرف ال O واشتغل على هيدي الريشيو. أخذنا ال OB وأخذنا ال OA. Z لل O هي 0 والZ لل B على Z لل A بعدنا مطلعين الأنسر تاعولها. Pay attention لقينا ال pi over 2 so the argument here is pi over 2 which is equal to 90 degrees. So we can say the two sides OA and OB are orthogonal to each other and consequently the triangle OAB is a right angled triangle. Solved example number 4. عندي هيدا التريانجل. I have to determine the nature of this triangle. So basically أول شي رح نطلع على الsides لأنه ما في عندي any information on the angles. I'm going to calculate the modulus of AB, AC and consequently BC. AB equal modulus ZB minus ZA. ZB and ZA are given. In order to find the modulus, apply the following formula, which is radical x squared plus y squared. Repeat the same steps for AC and BC. In any modulus, apply the following rule. Pay attention شباب صبايا للأنسرز اللي طلعوا عندي لأنه they are giving us a sight on the nature of the triangle. If I square AB, radical 26 square gives 26. Radical 13 square gives 13. Squaring, radical 13 square gives again 13. Adding 13 plus 13 gives 26. So AC square plus BC square is equal to AB square. So the converse of Pythagoras theorem here is satisfied, and we can say that triangle ABC is a right-angled triangle by applying the converse of Pythagoras theorem. Add to it that two sides are equal to each other. A triangle containing two equal sides is an isosceles triangle. So the nature of triangle ABC is a right isosceles triangle of vertex C.